Hello everyone, my name is Dustin Mance and this is my presentation for General Chemistry 2, Advanced Concepts 6, the nuclear bomb. So some of the first things to discuss are what is needed to make the nuclear weapon work, because of course there are other types of bombs that use conventional explosives or other means, but a nuclear weapon is slightly different in that it requires heavy metals that can produce a incredible level of power. The listed ones in the video were uranium-235 or plutonium-239 due to their heavy nuclei. The one that I will focus on within this presentation, however, will be primarily uranium-235. So I thought it would be justified to ask why this specific type of uranium is required, because there are different types of the isotope. And the reason why 235 is necessary is because it's stable enough to use for the bomb. It can be manipulated and stored somewhat safely, but once it reaches a critical mass within the bomb, it easily converts to the much more unstable form of uranium-236 as soon as it absorbs a neutron, and that will allow the bomb to begin its reaction. So as soon as it absorbs that neutron, it converts from 235 to uranium-236. This is where it becomes highly unstable, and it will then undergo nuclear fission, where it'll break apart into two smaller nuclei. As this fission occurs, there's a release of energy, radiation, but most importantly, a release of free neutrons. These free neutrons are vital to the continuation of the reaction. So why are the neutrons so important? And that is because they are what produce the chain reaction. As those free neutrons are released, they can be absorbed by other nuclei that are able to perform fission, and then once they perform fission, they too break down into multiple nuclei, who then release even more free neutrons. As these neutrons are being released, they can also impact other nuclei, and if they impact them, they can cleave them, which will then create even more smaller nuclei. As this is occurring, more and more fission transpires, and it's a chain reaction and produces a massive amount of energy, as all of these nuclei are constantly being cleaved and undergoing fission as the bomb is performing its reaction. The thing is, to create a nuclear bomb, there are more steps than just simply having fission, as fission itself would not produce the desirable level of energy and destruction that is necessary of a weapon of this scale. For this to happen, we need to have a critical mass, as they discuss within the video, or a specific density of fissionable nuclei. This can be done in multiple ways, as mentioned throughout the video. And of course, if there is not enough fissionable nuclei, then the reaction will cease, as it never really gets going, because there won't be enough free neutrons going and cleaving other nuclei and being absorbed by fissionable nuclei. So it fizzle out before it could reach its true destructive potential. However, if there is enough, then it becomes a self-regulating cycle and is only dependent on the number of secondary neutrons produced throughout the reaction. So it's vital that you have that critical mass, because without the critical mass, the destructive scale of the nuclear bomb won't fully get underway. The way that I found more fascinating to ensure that you reach critical mass was when they were explaining that the exterior of the bomb was lined with explosives, and the interior would be lined with uranium spread around a core, probably equidistant from each other. And then when that outer explosive goes off, the force drives the uranium together into like a central point, to where it condenses and it'll reach the desired density. And once it reaches that density, that is when it becomes unstable, begins fission, and has that mass release of neutrons that we had just discussed earlier. The initial explosion is near instantaneous, but there are other things that are causing massive damage with the nuclear bomb. Of course, there is that initial explosion, the shock wave, that causes immeasurable damage. Then you have the release of heat and light in those forms of energy, which cause even further damage. But there is one thing that lingers, and that is radiation, which, as in the video, cannot be felt or heard and is incredibly dangerous because of this. Because after the bomb goes off, there is a residual of alpha, beta, and gamma rays that can all cause different levels of damage, with the most concerning being gamma, as the only real way to be safe from those is to either be far enough from the source or to have things like lead protecting you from the source. And depending on the strength of it, it may require very, very thick lead to be safe, or else it will permeate the body. It can cause mutations, cancer, and all kinds of incredible health defects, along with lasting health complications. So just the fact that the bomb goes off and does instantaneous damage is not the only reason that that area is damaged. It will be difficult to occupy for some time, and to get the land restored back to a safe level is an incredibly difficult process and takes many, many years. Think of Chernobyl and how the radiation there is still incredibly unsafe. It's that type of thing to where, depending on the amount of material used and the exposure of the the radiation and its half-life, determines how long it is before it is safe to inhabit that area once more. I hope this explanation of nuclear weapons and how they function was adequate, and I thank you for your time and for watching this video.